Fun with Exponents Part 2. This time, we'll produce rationals from irrationals. Last time we showed that you can take a rational number, raise it to a rational power, and get an irrational number. And we did it by providing an explicit example. 2, a rational number, raised to 1/2, which is a rational number, is the square root of 2, which we showed to be irrational. This time, we'll show that we can take an irrational number, raise it to an irrational power, and get a rational number. Where do we even start? This is a proof I learned from reading a book by Paul Helmus. Last time we showed that the square root of 2 is irrational. So what a mathematician might do is say an example of an irrational number raised to an irrational power would be the square root of 2 raised to the square root of 2 power. So that leaves us with the question, is the square root of 2 raised to the square root of 2 power a rational number or irrational? And the answer is, I don't know. And in a way, I don't care. One of the things about being a mathematician is you're comfortable with things that not only you don't know, but you can prove nobody knows. And even though we don't know whether the square root of 2 raised to the square root of 2 power is rational or irrational, we'll be able to use it to prove our theorem. There are two cases. If the square root of 2 raised to the square root of 2 power is rational, we're done. We've taken an irrational number, the square root of 2, raised it to an irrational power, the square root of 2, and ended up with a rational number, no matter what that number is. That's case 1. Case 2 says, what if the square root of 2 raised to the square root of 2 is irrational? Okay, then consider this. The square root of 2 raised to the square root of 2 raised to the square root of 2. We know that this bit, the square root of 2 raised to the square root of 2, is irrational. And we know that the square root of 2 is irrational. And so all we have to say is, well, what's the result of this combination? Here's a cool thing, kind of a spoiler alert, but the square root of 2 raised to the square root of 2 raised to the square root of 2 is rational. So let's back up and look at something you know about exponents already. And we'll start with a concrete example. If you take 5 squared and cube it, it's as if you have 5 squared times 5 squared times 5 squared. And that is 5 to the 6th power, which of course is 5 raised to the 2 times 3 power. So 5 squared cubed is 5 to the 2 times 3 power. And this is generally true. A to the b, all to the c, is a to the b times c. And that's all we need. The square root of 2 to the square root of 2, that's our a to the b. Raising that to the square root of 2, that's our c. And so a to the b to the c is a to the b times c, so that's square root of 2 raised to the product of square root of 2 times square root of 2, but square root of 2 times square root of 2 is 2. And so the right side becomes the square root of 2 squared, which again is 2. So the square root of 2 to the square root of 2, all to the square root of 2, is 2. And so if the square root of 2 to the 2 is irrational, we've got our irrational raised to an irrational equals a rational. And so we've proved our theorem whether the square root of 2 to the square root of 2 is rational or irrational. We've never decided which is the case. Case 1, square root of 2 to the square root of 2 is rational. We're done. Case 2, square root of 2 to the square root of 2 is irrational. Then we raise it to the square root of 2, and that was 2, which is rational. In my opinion, that's a totally delightful proof.